right, hello there. We're going to look at systems of inequalities today. So we're going to be graphing inequalities with two variables. Remember, an inequality is a less than or a greater than sign. So just to kind of give you an idea of what the solutions are going to look like, remember back when we started chapter 3, we said we were solving an equation with one variable, and that gave us one number as a solution. And when we changed it to an inequality, that gave us a whole set of numbers as a solution. Now we bump that up to two variables. Think 2 dimensions, like a flat graph. Okay. When we solved with an equal sign with two variables, right? A system of equations, we got 1 point, an x value and a y value paired, right, as 1 point. Now that we're changing it to an inequality, we're going to get a whole set of points, and we're going to represent that as a shaded region in the xy plane. So the solution is a shaded region in the xy plane. Now, a shaded region, we can either include the boundary line, kind of like we included the endpoints with the brackets in our interval notation. So the equivalent of that in 2 dimensions is we're going to draw a solid line if the boundary is included. That's going to be when we have the equals bar, right? The less than or equal to, or the greater than or equal to. And then we're going to use a dotted line when the boundary is not included. So if we just have the less than or just the greater than, no equals on the bottom. Okay, just to give us a warm-up kind of into different parts of this process, part of our process is going to be to test if a point makes the inequality true. So I just have a couple of examples of that. So let's say we have this inequality, 5x minus 2y is greater than 8, right? We want to know if this point, 3, 1, is part of the solution. So the way we can test that is just to plug in the x value of 3 and the y value of 1 and see if we get something true or not. Right, so this would be what, 15 minus 2. So 13 is greater than 8. That's true, right? So yeah, this point would be a solution. 3, 1 is part of the answer. All right, what about the point 2, 1? Let's do the same thing. So when we plug in those values, we're going to get 10 minus 2 is greater than 8. So 8 is greater than 8. This may seem like a technicality, maybe it is, but we don't have the equals bar here. So technically 8 is not bigger than 8 or bigger than itself, right? It's equal, but not bigger. So this would be false. And we would say, no, 2, 1 is not part of the solution. Okay, so like I said, this is going to be part of the process of deciding where our shaded region is on the XY grid. Okay, so here are the steps we're going to use to solve or graph really the inequality. First, we're going to replace the inequality with an equal sign. So if I have a less than or a greater than, I'm going to take that out just for the moment and put in an equal sign. That's going to give me an equation for a line. And so I'm going to graph that line. If I started with a greater than or equal to or a less than or equal to, I'm going to graph it as a solid line. If I started with a greater than or a less than, then I'm going to graph it as a dotted line. So that's the boundary, right? I'm going to graph the boundary line. Then I need to do some shading, but I need to test to see where or which side of the line I should shade. So I'm going to choose a test point. I have a lot of freedom here. I can pick any point I want as long as that point is not on the line. And then I want to do what I just practiced with you, right? I want to check to see if that's a solution. I'm going to plug it in. Is it true or not? Okay, if that test point is a solution, then that means I found that side of the line, all the points on that same side are solutions. So I'm going to shade on that same side. If the point I picked is not a solution, then that means I am not going to shade where that test point is. I'm going to shade the other side, right? There are two sides to a line, so it's either going to be one side or the other. And I'm choosing my test point just as it says, right, to test to see which side I need to shade. Okay, so I've got a couple examples for you. We're going to start simple and work our way up. So first, we have this inequality. X is less than or equal to -1. So if I'm going to follow the directions I just had up here, I'm going to put in the equal sign. Right, this is a line. I want to draw it on my grid here. This is the boundary. Should it be solid or dotted? Because I have the equals, right, less than or equal to, this is going to be a solid line. I tried to get in the habit of writing this down because otherwise I forget when it's dotted to draw it as a dotted line, because it's something we're not really used to. Okay, maybe you already know what kind of line this is. If you don't remember, what this means is that the x value is fixed to be -1. So the x value is always -1, and the y value is not part of this equation. It can vary to be any number we like. So maybe we have -1, 0, and 1. So let's plot this. So -1, -1, -1, 0, and -1, +1. So this is a vertical line. Right? Remember, it's solid. I really should have these labeled, sorry. Okay, so here's our boundary line. We are either going to shade on the left or we're going to shade on the right. Because this one is vertical and not sort of diagonal, maybe it's a little easier to tell straight from the original problem which way we're going to shade. Right, I want to shade points whose x values are smaller than -1. Okay, if you wanted to pick a test point, I love to pick 0, 0 as my test point if it's not on the line, right? So let's say I want to test the point 0, 0. All right, I think you could get away without testing a point, like I said, because this one's kind of simple, but I'm going to go through the steps anyway. So I would take this and plug it into my equation, right? I only need the x this time. So 0 is less than or equal to -1. Is that true? Is 0 smaller than a negative? No, that's false, which we kind of already knew. We kind of suspected we were going to shade to the left. This is not a solution, which means none of the points over here on the right, these are all not solutions. Okay, so I want to shade on the other side of the line where the x values are smaller than -1. Okay, usually a pencil works best for this shading, but it doesn't have to be perfect. Okay, hopefully that kind of gave you a basic idea of the process. So let's try one that's a little bit more challenging. This one is also from your book. And I kind of meant to not have these here, but that's all right. All right, so the first step again is to put in the equal sign. So x plus y equals 3. Any method that you've used in the past to graph a line would be appropriate to use here. So I meant to kind of not have these here, but that's okay. Any two numbers that add 3 are going to make a point on this line. So you could really do it that way. A lot of people like to have it in that mx plus b format. So you could take the equation and subtract the x over to the other side if you like, right? And then choose some x values that you want to plot. Okay, you're welcome to graph the line any method you like, anything you've already looked at before. So is this line going to be solid or dotted? I look at my inequality. I do not have the equals bar, so this is a dotted line. Okay, so since I already have these here, I guess I'll go ahead and use them. So I have 3, 0, 2, 1, 1, 2, and 0, 3. Notice this is my y-intercept of 3. I'm going down 1 over 1, right? Because I have a -1 slope. Down 1 over 1, and so forth. Okay, and it's dotted. Okay, this line also has two sides. I am either going to shade below and sort of to the left down here, or I'm going to shade above and to the right. So I need to decide which side of the line do I shade on. So I want to pick a point. Again, you can pick any point you like as long as it is not on this line. 0, 0 is my favorite because it makes the math really easy, but really could have picked a point out here if you like. It doesn't matter. So I'm going to test the point 0, 0. It is important that you always go back to the original inequality so that you don't get fooled by some error you may have made along the way. So we got 0 plus 0 is greater than 3. 0 is not greater than 3. That's false. So just like the last question, right, this is not a solution. So none of these points over here are solutions. I need to shade on the other side of the line, this side over here. Okay. All right, so now we're going to up it a little bit, and I got one more example. In this chapter 4, we're trying to look at a system. So now we're going to make it into a system of inequalities. So we're going to have more than one inequality. Our solution is still going to be a shaded region, but we're going to treat each inequality just like we've done here, go through those steps for each one, and then the overlap of the shaded regions is the solution. So we're going to shade twice, and wherever our shading overlaps, that's going to be our final answer. Okay, so let's try that out. Oh, I have two. Yes, I have two. Okay. So first we've got one that's a little more simpler. So we have y is greater than x plus 1. So we'll call that number 1. We'll put in the equal sign. Lucky for us, that's already in mx plus b. So pick a few points. Maybe you want to do -1, 0, 1. Whatever you like, plug them in. -1 plus 1 is 0. 0 plus 1 is 1. And 1 plus 1 is 2. So I've got -1, 0. 0, 1, and 1, 2. Whoop, stopped myself just in time. Is this going to be a solid line or a dotted line? I don't have the equals bar, so this is dotted. Okay, so let's draw that in as a dotted line. Okay, and then we want to pick a test point, right, and see where to shade. So again, I'm going to test my favorite point, 0, 0. All right, and I won't write this down because I'm kind of out of space here. All right, so if I plugged in 0, 0, I'm going to go all the way back up here. 0 is greater than 0 plus 1. Again, that's false. It did not work. So I don't want to shade on this side where 0, 0 is. I want to shade on the other side. So that would be up here. Okay, so that's the first half of this problem. Then I want to do the same thing for the second inequality. So I'm going to put in the equal sign, y equals 2. Okay, the x equals that we did a minute ago was a vertical line. This is a y equals, so this is going to be a horizontal line. But the same thing applies. The y value is fixed at 2. And the x can be any number we like. So I'll just pick -1, 0, and 1. So I have -1, 2, 0, 2, and 1, 2. This is also just less than, not equal to, so this is dotted straight across. Okay, here's another one that you could probably reason out without using a test point. We want points where the y values are smaller than 2. Pretty sure that's going to be below, but I'm going to go ahead and test my favorite test point, 0, 0. So I take just the y value. 0 is less than 2. That's true. So I'm going to shade on the side of 0, 0. This is a solution, and all the points on the same side of the line are also a solution. Okay, now that I've shaded twice, you can see where the shading overlaps. It's not a bad idea to help your teacher out and make that part the darkest so she knows for sure what your answer is. Okay, so this kind of triangular wedge would be the final answer. Okay, so that's the basic idea, right? We take each line, we graph them, solid or dotted, individually, we do their shading, and then wherever their shading overlaps is our final solution. Let's try one more, then we'll call it quits. Okay, if I remember correctly, this one is a little bit tricky, but that's okay. All right, so let's call this number 1 and number 2. Again, if you want to put it in mx plus b format, you can do that. So you could subtract the 4x over to the other side, and you'd get y equals -4x plus 4. Okay, and then you could pick a couple of points to plot. Let's see. My go-to is -1, 0, and 1. Let's see if those are going to work. I think this -1 might be off the grid. So if I put in -1, that's going to make this +4 plus 4 is 8. It's not actually going to fit on our grid, although we could scale it, but I don't like doing that. If I put in 0, this will be 4. That should fit. If I put in a 1, negative 4 plus 4 is 0. Let's just do a 2. Negative 4 times 2 would be negative 8 plus 4 would be negative 4. All right, so these three should fit on my grid. So I have 0, 4, 1, 0, and 2, negative 4. Okay, solid or dotted? I have the equals bar, so it is solid. Okay, 0, 0 is not on the line, so I'm going to test 0, 0. And remember, it's really a good idea to go all the way back to the original. So this would be 4 times 0 plus 0 is less than or equal to 4. This is 0 plus 0. So 0 is less than or equal to 4. That's true. So 0, 0 is a solution, which means all the points on this side of the line are solutions. So you will want to shade. Okay, that's line number 1. Now let's graph line number 2. If you want it to be in mx plus b form, that's going to take a little bit more work, but that's okay. I'm going to put in the equal sign. I'm going to subtract the x over to the other side. And then I'm going to divide everything by negative 3. So that gives me y equals 1/3 x minus 1. Okay, and we could do the same thing, right? We could do an, well, you know what? Let's see. Multiples of 3 would be really good, actually, because I have a 1/3 here. So maybe negative 3, 0, 3, 6. Let's try that. Okay, you could have used the other ones and just plugged them into your calculator or done some fraction work. I'm just trying to make it come out to a whole number because I'm lazy. All right, so 1/3 times negative 3 would be negative 1, minus 1 would be negative 2. 0, 1/3 times 0 would be 0, minus 1 would be negative 1. 1/3 times 3 would be 1, minus 1, 0. And then 6, 1/3 times 6 would be 2, minus 1 would be 1. So we have negative 3, negative 2, 0, negative 1, 3, 0, and then this one's actually off the grid, so we'll just stick with these three. Solid or dotted? Solid. Okay, and then choose a test point. I'm going to use 0, 0 again. And remember, I'm going to go all the way back to the beginning. So I'll have 0 minus 3 times 0 is less than or equal to 3. That's 0 is less than or equal to 3. That's true. So again, I'm going to shade on the side of 0, 0. That means I'm going to shade above here. I'm looking at this line right here. Okay, so now that we've shaded both, you can see where the shading overlaps. This one actually was not as tricky as I thought. So this is our final answer right here. This sort of kind of a wide triangular wedge. Right? You get the idea. All right. Well, I hope that gives you kind of a good demonstration of how to graph an inequality. We've kind of hit all the high points, the solid or dotted, right? Graphing the line and then shading. You can't answer this question without doing the shading, so make sure you understand that part so that you're able to complete these questions. All right, well, good luck, happy studying, and we'll see you in the next video.